this demonstration, we're going to cover Lab 8. Lab 8 is concerned with georeferencing archaeological site sketch maps that were made by Nicholas Dunning back in the late 80s. He's at the University of Cincinnati. And each one of the sketch maps has a scale and a north arrow and a centerline UTM coordinate that Dunning recorded. So with that in mind, let's go ahead and take a look at what's in the lab. We'll unzip the lab, already downloaded it. So I want to get these things out. So we'll copy them back into Miller Lab 8. And we got all that out, and just copy the lab back into the folder as well. Okay, let's take a look at what we have in here. I have a PowerPoint presentation. We'll look at that in just a moment. Here's the lab. This is a Word doc, and it has some archaeological sites. You'll notice that they have the name, abbreviated UTM, the zone, and some quad information, an easting, a abbreviated easting, a northing, abbreviated northing, and some remarks. We're going to be working with easting and northing. Those numbers are meters. With respect to easting, this is 238,600 meters east of the western edge of the UTM zone. And the northing is 2,219,300 meters north of the equator if you're in the northern hemisphere. And that's for this site of Zula. So we're going to keep that open. We'll be working with those in a minute. And this is the center point of the site. We're making that assumption because that's what Dunning says. Let's go find Zula and open the TIFF file. So this is Dunning's sketch map of Zula. And the reason that I even did this project is back when I did my dissertation, I studied water resource management. I had a grant from the National Science Foundation, but it wasn't enough to visit as many sites as I felt were necessary to have a representative sample to look at adaptive strategies with respect to water. So Dunning's maps have water features on them. These red dots are choltuns. Choltuns are cisterns that capture rainwater during the rainy season and store it for use during the dry season. Now, if we look at this map, it gives the name of the site, Zula. They have some contour lines on here. This is a platform with a structure, stairway. The red dots, again, are choltuns. The contour interval is 5 meters. You can see that legend says choltun. It has a north arrow, that's magnetic north, and it has a scale. The scale is 50 meters, from 0 to 50 meters. Now, if you'll notice, that's about the exact length of this line. So I was trying to figure out how I can use just the information I have, the UTM coordinate for the center of the site, and a scale and a north orientation to georeference these maps. We all know that you need a minimum of 3 points, reference points, to georeference any map or image. And if we extend this scale on the horizontal, so I drew a line in Photoshop, and that's this line right here, which is 50 meters, the same length as that. And then I rotated it 90 degrees and drew another line that's 50 meters, the same line, and put them together with the intersection. So from here, this point, to here is 50 meters, and from that point to that point is 50 meters. So how can we georeference this image? We have this. It's known, it's in that Word doc. That's the center UTM of the site. If we have a known, we can calculate the UTM of this and the UTM of that. We can geocode 3 points, the center point, a center north, and a center easting point, then we can put them into the GIS. Then we can interactively insert this image and georeference it using those 3 points. That's this exercise, along with the georeferencing of, I think I asked for 4 images, I'm not sure. Along with georeferencing these site maps, you will be asked to digitize and just use your imagination. I have in there a platform feature. That's a platform. I have a structure. This is a structure, the black thing. It's on top of a platform. The ancient Maya built on top. So platforms, just to get off the ground, you wouldn't want to have rodents running through your living quarters. They didn't either, so they wanted to be elevated. Plus, they were above the muddy soils. Okay, so we have Zula. I'm going to close this. Well, I'll leave it open for a while because we're going to have to work with it. So, in order to start this lab, the first thing we need to do is open up a Microsoft Excel spreadsheet because that's what we're going to work with. So, I'm going to open up a spreadsheet. And we're going to have 3 coordinates per site. So, up here, in A1, I'm going to cap lock, and I'm going to put location as an attribute. I'm going to type easting. For B, northing. For C, D is going to be zone, and E is going to be name. So that's the site name. Now, we'll only want to have the site name on one of the 3 points because you don't need the site name busying up your map window. Okay, so once again, these are all caps, no spaces. If you want to have a space in there, you put an underscore, no operators. And let's go ahead and format the cells. And they're already general. That means they could be a number or they could be text. Let's leave it like that, and that's fine. Okay, I'm going to use Zula to start with, and I have 3 abbreviations that I use for location. I used DZU for Zula and CC for center center. DZU CE for center easting and DZU CN for center northing. Nice code. And you can keep doing different sites down here, just registering different sites if you want and using the UTM coordinates. The name is Zula. We only put that in the center point. Okay, the easting. What would the easting be? Let's go to the Word doc. And the Word doc for Zula, the easting is 238,600 for the center center. I'm going to copy that in there. And the northing is 2,219,300. Copy that and paste that in there. And the zone, they're all 16. So we're going to type the zone as 16. The zone is going to be important. Trust me, it will be very important when you get to the final because I have an exercise where all of these sites might not be in zone 16. Some of them are in 15, and I'll show you how the redundancy works. There is a redundancy in easting and northing. Okay, let's minimize this for a minute. And I'm going to go to minimize that. I'm going to go to this maps PowerPoint for a minute and just show you a couple things. There are 2 different coordinate systems that we work with in GIS. The first is polar coordinate systems, and the graticule that we see on globes today was developed by the Greeks, and it enables us to plot points in degrees of latitude and degrees of longitude, so latitude, north, south, longitude, east, west, for any point on the planet. And if you have 2 points, then you hypothetically can calculate the distance between them, hypothetically meaning if in fact you knew how to do the trigonometry involved. And that's a complex calculation because we know that lines of latitude run east to west. Latitude is a north-south direction, and they're parallel. But lines that demarcate longitude run north-south. They're called meridians, and they converge at the pole. So just knowing that, you know that a degree of longitude, east-west direction, at the equator is its greatest distance. And as you move north or south from the equator, a degree of longitude decreases until you get up to the pole, and all of those meridians converge, and a degree of longitude is basically nothing. The other coordinate system we use is a Cartesian coordinate system like UTM. They are defined by perpendicular distances and directions from a fixed x and y axis. You remember this from back in your good old geometry days. The x-axis for UTM is substituted by easting, so that's the horizontal. The north-south axis, the y-axis, is northing. So we can plot points as long as we have an x and a y, an easting and a northing. We can plot those points. I'm going to move to, well, this slide here, if you see 1 degree at the equator is 111 kilometers or 69 miles using latitude and longitude. By the time you get to Washington, D.C., it's 88.8 kilometers or 55.2 miles. So therein lies the geometry and the trigonometry. You need to calculate that. This is a universal transverse Mercator grid. So there are 60 zones running from east to west, and they run from approximately 80 degrees north to 80 degrees south. They're vertical in nature, and here's Alabama. We are in zone 16. Here's the Yucatan Peninsula. You'll see it's in 16 and a part of it's 15. A easting and a northing can be redundant. Basically, using this example, a easting coordinate is meters east from that western edge of the UTM zone. So if you had a gate of 1 meter and the easting was 238,600, it would take you 238,600 steps from this line that demarcates zone 15 on the west to get to whatever point you're plotting. Northing is meters north of the equator. So in the case of Zula, it's 2 million some odd meters north. That means that if your stride was 1 meter, you'd have to take a little over 2 million steps to get to that point. Very simple and straightforward. The other rule of thumb is that easting increases as you move east and decreases as you move west. Northing increases as you move north and decreases as you move south. And by the way, if you're in the southern hemisphere, this is considered 10 million instead of 0. So northern hemisphere, it's 0 and counts upward. Southern hemisphere, we start at 10 million and subtract off. That's universal transverse Mercator. I think that's enough of that. We'll end that show. And get back to our Excel spreadsheet that we're working on. Let's take a look at Zula. I know I have that open. There you go. I'm going to have to scoot some of this stuff out of the way so you can see this. Okay. Maybe we'll be able to see this. Let's see. A little bit more. Okay. So, Zula, center, 238,600 east by 2,219,300 north. That's that point right there. If we want to know the easting for this point, which is Zula north, we're not moving any additional meters east or west of this center line. So the easting for this point up here is going to be the same as the easting for center center. So I'm going to go down there and type 238,600. The northing for this point, remember the scale is 50 meters. So the northing for this point to this point is an additional 50 meters because we're walking north. There's your scale bar. So the northing would be 50 meters more than 2,219,300. So it's 2,219,350. That's the northing. This should plot a point right here. The Zula center easting, okay, if we're going from this point, traveling to this point, and this is north, then that has to be west. If this line is 50 meters, then going west 50 meters means we have to subtract 50 meters off of the easting of the center. So it's 238,600 means it's 238,550. Okay. Are we moving further north or south? No. So the northing for this point right here is going to be the same as the northing for that point right there, which is 2,219,300. And what you can basically see is you can see the alternatives here. These are alternate back and forth. Okay, I'm going to type that in because this seems to be a smaller text. 22193. Huh. I don't know why it's doing that. I don't like that, so I'll make it 11. Hopefully that won't hurt anything. Okay, we'll type the zone 16 in all of them. We're not going to use that for a label. We'll need Zula. Okay, I think we're ready to geocode this. So I'm going to close this. I'm going to label my sheet Dunning. Yeah, let's make it Dunning underscore sites. Okay. Sheet 2 I'm not going to use, so I'm going to delete that. And sheet 3 I'm not going to use, I'm going to delete that. And we need to save this, but we need to file save as. You all know that GeoMedia will only take Excel 97 2003, so we want it in that format, and we want to put it in our folder for Lab 8 on the C drive. So we go to Lab 8, and let's call this one Dunning. Okay, so we should be good to go. This should work, hopefully. And by the way, you need to close this to attach it. Okay, let's open up GeoMedia. We're going to open up a blank Geo workspace. And we're going to make a new connection. And we're going to connect to Yucatan. Browse. Go to the Lab 8 folder. Yucatan 3 MDB. Okay. Let's go ahead and display country. So legend, add legend entry, and country is the only thing on there. There you go. Okay, just for the fun of it, let's go ahead and view GeoWorkspace coordinate system and the projection space. Let's change it to Universal Transverse Mercator. And the project, we have to, when we do UTM, check, verify the projection parameters. It's always defaulted to 15. We want to make it 16. Okay, and okay. And you'll notice it just kind of tilted this just a little bit. Let's put a north arrow in there, and we'll view a scale bar. And guess what? We're working in the Yucatan Peninsula, which is south of the border in Latin America, and those folks down there seem to be ahead of us in that they are looking at the metric system, kilometers. I like the double block, so let's go ahead and make this double block. Just gives me a little color to look at. Okay. So we have that. Now let's create a new warehouse, new warehouse. Here we take the default, normal MDT. We have to go to our folder again. Everything must be created in your folder. Don't create outside this folder. You'll lose your data. Call this Dunning. Save. Okay. Now what we want to do when we geocode coordinates, we have to attach a spreadsheet. We could actually key in coordinates, but that's not really the best way to do this. Let's go ahead and attach the spreadsheet. So we do that by going to Warehouse, Feature Class Definition, Dunning, Attach. Here, when we attach, it always asks what format of data we're attaching. It's Excel 97. We'll browse. We have to go to the Lab 8 folder and pick up Dunning XLS. And there it says Dunning Sites. That's why I deleted all those other worksheets. I don't know why it puts that little tail on there. Well, I do. It's an underscore. And if you have 2 or 3 sheets that are named the same, that underscore will be followed by a numerical value for the number of sheets. So we're just going to attach Dunning Sites. Okay. If you want to see what it looks like, we can go to Edit, Attributes, and there's the attributes. It has a location, an easting, a northing, a zone, and a name. That's a text feature. So everything so far is pretty good. Now what we need to do is we need to geocode those coordinates. So in order to do that, we go to Analysis, Geocode Coordinates. Geocode attributes in, we want to pick the spreadsheet. Here, the first time you geocode coordinates using UTM, you have to check the coordinate system. After that, just like geocoding points for the schools and churches in Lat Lawn, once you do it one time and you haven't closed the Geo Workspace and saved it, it'll stick to wherever the last setting was, but it'll go back to defaults. The coordinate system is projection space. We need to change it to UTM. It has to know what we're dealing with here, and it's not 15, it's 16. Okay. Now you'll notice that instead of latitude, like when you're geocoding schools and churches, it's asking for positive east meters. Easting, that's easting. Positive north meters is northing. Now we got this green dot. Let's change it to red. And we're going to display it in the map window. We really don't need to see the data window. And voila, there's the points. Now, if we would zoom in here, we would see that they are in the configuration of the scaled center that I put in the map. In order to do that, let's just go ahead, display all on the country and fit all. And you'll notice we have 3 points. And they're in the right position. There they are. So we could actually move that over. If, in fact, you do this and you find out that, number one, this point is down here when it should be up here, or this point is over here when it should be over there, you made an error in the calculation of northing and easting. Be cautious of these maps because some of the maps have a 50-meter scale, some of them have a 100-meter scale, and some of them have 20-meter scales. So you have to be aware of that when you're doing the addition. These are correct. So now I need to get Zulaw interactively in here. To do that, insert, interactive image, browse. We're going to go to the C drive, Lab 8, and I'm going to pick Zulaw TIFF. It's already a TIFF, so it doesn't have to be changed or converted in from JPEG to TIFF to output a GeoTIFF. It's in the correct format. Open. We're going to put it in Dunning, and we're going to call it Zulaw TIFF. Okay, Zulaw TIFF. Click OK, and we're just going to draw it in right there by left click, hold, Draw your box. There's the map. If this map doesn't come up or doesn't appear, you've done something wrong. You didn't name it. You put it with a duplicate name. There's lots of things that you could have done. Okay, now we're ready to georeference. So basically, you remember what georeferencing is. We're going from image to point with geometry, image to feature. The outside of this line is the correct measurement. This line's probably about 2 meters thick in scale. So you wouldn't want to do inside because this would be 48 meters, not 50. So we want this to correspond to that, this to correspond to that, and that to correspond to that. This is a piece of cake because you're going to points. You don't have to do a lot of zooming in and out. So in order to do image registration, we go to Tools, and we go down to Image Registration. And I've highlighted this. It's green, new. It has to be highlighted. And we're going to call that one Zula. I believe in the lab, I'm asking you to do 4, georeference 4, maybe. You might want to georeference all 10 of them. I believe there's 10 of them. There may be not quite 10. Once we have it named, add points. Now you notice we have the bullseye crosshair with this snap tolerance. And let's be a little accurate. I zoomed in, right click, and I'm going to get right there. Left click once. That's my one, fit all. And I don't even have to zoom in. Watch this. I just get near there and I get that A. It's going to snap onto that point. It's within snap tolerance. The next one. That's 2. Don't have to zoom. There it is. 3. Fit all. 3. Okay. I'm going to zoom out a little bit. Right click. Double left click in the white space. I had a little spastic click there. You're never going to get a residual with only 3 points. It has to have 4 to calculate residuals, so the residuals look super. They're 0. Everything looks good. Let's go ahead and register. The map popped over there. And let's change the color of these points to blue and push them up above the map and see how good we did. Look at that. Perfect. So now this is georeferenced. We could turn back on the country and fit all. And you'll notice that Zula, in fact, the map is covered by the point features because they do not change. But if we zoomed in, ultimately we'll see Zula. Okay, so let's display off there, fit all. And now I'm right clicking or escaping to get out of zoom feature. I want to make this a geotip. So I left click, it's highlighted, warehouse, output to geotip, and we're going to go to C drive. It was going back to lab 6. That's the last time I did that. And it is Zula, so why not just click on Zula once, left click, and call it Zula GeoTIFF and save. GeoTIFF tags written successfully means that it was output okay. If you get an error message that says that output of GeoTIFF is not supported by this projection, go in and change the projection to something else. UTM is a safe one. I believe hours equal area is a safe one. Cylindrical, equirectangular is probably the one that it doesn't, is unsupported. Why is it unsupported? Because it's not able to do the trigonometry involved in warping this feature. Okay, I'm going to turn this feature off, and I'm going to insert a georeferenced image. Automatic is the mode. You don't have to. You could change the geotip, but leave it automatic. That way it recognizes anything. Browse to the C drive. Go to Lab 8. Only click the folder and go OK. And here's Zula geotip highlighted. Arrow to the right. If you get a warning message here, it's not a geotip. We're going to put it in Dunning, and we want to call it, see, Zula TIFF is already up there. That's the last image we interactively replaced. So we want to name this something else, and it's Zula GeoTIFF. And add a new legend entry. If you don't check that box, nothing will happen. You can apply to see your work, and OK or close. And there you go. So now that's in there. So we've georeferenced, we've taken a map, a sketch map that had no geospatial value in a GIS. We innovatively calculated 3 points of UTM coordinates, and we were able to georeference this. Now I want to show you one other issue that can come up. I'm going to display on the country and fit all. Okay, and I'm going to push it. You'll notice we can't even see the map now. We could if we did that. That's it right there, the little green speck, because it's highlighted. Um, Here's what we're going to do. I'm going to geocode the same coordinates for Zula, but I'm going to make a mistake and geocode them with the wrong UTM zones so you can see what happens. So I'm going to go to Analysis, Geocode Coordinates, Dunning Sites. Now you notice I've got to click on the coordinate system in the projection space, projection parameters. I'm going to take this back to 15. Okay, okay. Let's select the easting, select the northing. Remember, there's a redundancy here, and there'll be that. And let's click OK and fit all. And you'll see here's where they are. They're over here now in zone 15. So that's the functional equivalent of the northing and easting we have for this particular site down here. And I'm not going to move them up above because I'm going to show you how to um, fix some errors. Well, let's actually just delete this. And that's a query. So if we went up to analysis queries, this is it right here. I'm going to delete this. Okay, close. Now what I'm going to do is I'm going to push these up here. So there's our points. I'm going to go in here and show you the map. Okay. What I'm going to do is I'm going to save the Geo workspace. So File, Save Geo Workspace. Let's put it in our folder. So it's got to go in the Lab 8 folder. And you're going to call it, well, you're not going to call it Line Miller. I am. Lab 8. Okay, so it's saved. Now what we want to do is I'm going to change the easting of this point right here. I'm going to add 50 meters to it. So we're going to close this. I'm going to go into the folder. I'm going to open up Dunning Sites. And that was Zula North. Instead of 350, oh, that's northern. Easting, I'm going to make this 6, instead of 600, I'm going to make it 650. Just to impose, to insert a mistake in there. And I'm going to close this. Now I'm going to double left click and open up GeoMedia again. Now you'll notice that that point moved over to here. This demonstrates a couple things. One thing that it demonstrates, one particular situation that it demonstrates is that when you have attachments in GeoMedia and when you go through any kind of analytical function like geocoding coordinates, whatever, when you launch GeoMedia, the Geo Workspace, it goes through and accomplishes all of those tasks in order every time you open it. When it closes, those things go away. They go into the ether. So you'll notice that if you close everything down, you can fix errors that exist in the data. So if this point was in fact over here in the wrong direction, you would save your Geo workspace. You have to close the Excel spreadsheet. You have to close the Geo workspace because I can show you right now. This will make a fool of me. This probably won't open. It shouldn't. See, Dunning XLS cannot be accessed. It says the file is corrupted. That's not the case. The case is it's a sharing violation. So you can't open it while GeoMedia has its greedy little hands around it. So we can fix this. I'm not going to save this. I'm just going to close it. And I'm going to go into the Excel spreadsheet again. And I'm going to get this back to 600. Save it again. So if you do make a mistake, um, they're not fatal. So it's back where it belongs. Okay, I'm going to File, Save to your workspace, turn on the country. It's already on, fit on, and there you go. So you saw, you notice that there's a redundancy issue with UTM coordinates. You can make mistakes. You need to know what zone you're in, especially in an area like Yucatan, where in fact, if I draw this line down through there, um, that's about the boundary of between 16, zone 16 and zone 15. So there are archaeological sites in 15, and you would have to do something about that, probably geocode them separately using a separate spreadsheet to get everything to work out properly. So that's the lab. I've already saved it. I've got everything in here. I'm going to take this maps um, and I'm going to, well, I thought I was going to. I'm going to, hello. I'm going to take these maps and I'm just going to delete it. And go back to Weinmiller Lab 8. So C drive, right click, send to compressed folder. You may have to let this do this on the C drive. That's the folder you send to me. If I double left click on it, inside is a folder. I want a folder, one folder inside, and then all of your work in here. I have the Geo workspace. I have the Dunning XLS. If I sent this to me, I'm a lonely person. If I sent this to me, I would get an email and I would have an attachment. I could open it up on any C drive on any laptop that has this software, and everything would work out fine. So that is the demonstration for Lab 8. Enjoy.